Intermediate Algebra Section 3.3 Solving Application Problems Involving Two Equations. And in this video, we'll take a look at mixture problems. In this problem, I have the following. Good Eats wants to make a 20-pound mixture of almonds and cashews that sells for $10.75 per pound. Almonds are sold for $10 per pound and cashews are sold for $12 per pound. How much of each type of nut should be used in the mixture? There's a lot of information given here, so I have a table to help organize this information. And going back at the beginning of the problem and filling in the slots that we can, Good Eats wants to make a 20-pound mixture. So under mixture, which we're talking pounds, and I'll identify that here in the heading, they want a 20-pound mixture of almonds and cashews, and it sells for $10.75. So the price per pound is $10.75. They're not telling us how many almonds, so we can pick a variable to represent the amount of almonds, nor are they telling us the amount of cashews, just that an amount of almonds and cashews are added together to give us 20 pounds. The next sentence tells us that almonds are sold for $10 per pound, so we can put that value in, and that cashews are sold for $12 per pound. To fill in this final column, which is cost, we will take the amount times the price per pound to give us the cost. So X unknown amount of almonds at $10 a pound would cost 10X. Cashews at an unknown or variable Y, pounds times 12, gives us a 12Y. And here for our mixture, we have 20 pounds at $10.75 per pound, results in a cost of $215. From the table, we can generate two equations. Since we have two variables, we need the two equations, and here's where the first one's going to come from. X plus Y is equal to 20. The other source of our equation is going to be here with the cost. 10x plus 12y is equal to 215. We have two equations, two unknowns. If we use the elimination method and, for example, decide to eliminate the x term, for that to happen, this x, instead of having a 1, would need a coefficient of -10. So I'm going to multiply every value in this first equation by -10, giving us -10x, -10y, and a -200. Adding it then to the second equation that I'm not going to do anything to, results in the x's canceling out. A -10 and 12 leaves a 2y. -200 plus 215 leaves 15. Dividing both sides by 2 results with a y is equal to 7.5. So we now know the number of pounds of cashews. Almonds then, we will replace y with the value that we found in either one of the equations, and this first equation is probably the easiest to solve for that value. So x plus y, which we now know 7.5 is equal to 20. Subtracting 7.5 from each side leaves us with x equal to 12.5. We could verify our answers in the second equation to be sure that we do have the correct solutions. And so our final answer will be number of pounds of cashews, and cashews were represented by y. We will say 7.5 pounds. How many pounds of almonds then for our final answer? We just found to be at 12.5. Other mixture problems present themselves as percentages, and here we have an example. that says Sean wants to make 5 liters of a 40% hydrochloric acid solution by adding a 60% solution to distilled water, which has no hydrochloric acid. How much water should he use? Again, I'm going to use a table to help represent this information. We'll go back through the problem to fill in the cells that we have here in the table. Sean wants to make 5 liters, so that would be the amount. And just to indicate what that amount is measured in, we will put a 5 there. That's 40% hydrochloric acid. Furthermore, he's going to do that by adding 60% solution, and it's not stated how much, so we'll represent that with an unknown. It's 60%. To distilled water, again, an unknown or undesignated amount, which the problem helps us out by telling us that it has no acid in it. And from here, we've filled in as much as we can, at least with the information given in the problem. Now, to fill out the rest of the table, we have an amount that we can multiply by the percent to give us the pure quantity. And this last line is probably the easiest to help understand that. We have 5 liters or a 5-liter solution at 40% hydrochloric acid. How much is pure hydrochloric acid? We would multiply 5 times the 40%, which in decimal equivalency would be 0.40 when we move the decimal over 2 places. So we're going to take 5 times 0.40, which results in 2. 2 liters of this 5-liter solution are pure hydrochloric acid. We'll do the same, converting our 60% into a decimal equivalency, either 0.60 or just 0.6. Multiply it by the amount, which we don't know, so we will end up with a 0.6x, and y times 0 is 0. So our table is filled. We're now ready to generate 2 equations because of the 2 unknowns. Here's one source for our equations. As far as quantity, the 60% solution plus the water results in a mixture of 5 liters. The second equation comes from here. Our pure hydrochloric acid plus none from the water is equal to the 2 in the mixture. What we're doing is we aren't adding any more acid, we're just diluting it by adding the water, which is reducing the percentage. And this equation, because of the 0, has no impact on this. We can simply solve for the variable because we have one equation with one unknown. Dividing both sides by 0.6 is going to give us 2 divided by 0.6, which results in 3 1/3, and this is the amount of the hydrochloric acid. We're not done though. The problem asks how much water should be used, and that was our y variable. But once we know one of the 2 variables, we can replace that in our other equation. X we found to be 3 1/3 plus our unknown water is the volume that the mixture was equal to. Subtracting 3 1/3 from each side to solve the equation leaves us with y is equal to 1 2/3 liters, which was the water that we were looking for to answer our question. Of course, we want to check this by replacing the x and y values with the values that we found to be certain that we've solved it correctly.